There is a moment every developer eventually reaches. You are 6 months into a project. The codebase started clean, but now your database is everywhere. Your business logic is split across controllers, services, and query builders. Nobody knows where a rule actually lives. Adding a feature means touching 5 different files and hoping nothing breaks. Testing is painful because you need a live database just to check if a discount calculates correctly. That moment is what Onion architecture was built to prevent. Not by being clever, but by being ruthlessly organized about one thing. What depends on what? Onion architecture was created by Jeffrey Palermo and introduced in a 4-part blog series in July 2008. The pattern has since become a foundational approach for enterprise software, used heavily in the .NET ecosystem with ASP.NET Core, and in Java applications built on Spring Boot and Quarkus. In this video, you will understand exactly what Onion architecture is, how its 4 layers work, how a real request flows through those layers from the outside world to the domain and back again, how it compares to the other architecture patterns in this series, and, most importantly, the 4 mistakes that will silently destroy everything good about this pattern if you let them into your codebase. Let us start with the problem it solves. To appreciate Onion architecture, you need to feel the pain of what it replaces. In a traditional 3-tier or layered architecture, you have a presentation layer at the top, a business logic layer in the middle, and a data access layer at the bottom. Each layer depends on the layer below it. This feels logical. Information flows downward. Your controller calls your service. Your service calls your repository. Your repository talks to the database. Now, imagine the business decides to migrate from one database to another. You update the data access layer. But because your business logic layer calls the data access layer directly, it is also affected. And because your business logic layer sometimes builds queries or uses database-specific types, those changes ripple up. You are not just changing a database, you are touching your business rules. That should never happen. The deeper problem is this. In a traditional layered architecture, the database is the foundation. Everything builds on top of it. Your business logic depends on infrastructure. Infrastructure is the least stable, most frequently changing part of a software system. Databases change. Frameworks update. APs get replaced. By making your business logic depend on the thing that changes most often, you have created an architecture that is fragile by design. Jeffrey Palermo looked at this in 2008 and proposed a simple but radical inversion. Do not make the business logic depend on the database. Make the database depend on the business logic. Put the domain, the heart of the application, at the center of everything, and let everything else orbit around it. Onion architecture is visualized as a set of concentric rings, like the layers of an onion. The further out you go, the more infrastructure-focused and changeable the code becomes. The further in you go, the more stable and domain-focused it becomes. There are 4 primary layers. Let us go from the inside outward. The first and innermost layer is the domain model. This is the heart of your application. It contains your entities, the real-world concepts your software models. An order, a customer, a product, a payment. These classes contain pure business rules and state. They have 0 external dependencies, no database annotations, no framework references, no imports from any outer layer. If you opened the domain model in isolation, you would be able to understand what the application does, what it is about, without knowing anything about how it stores data or how it receives requests. The second layer is domain services. This is where business behavior lives that cannot be placed inside a single entity because it involves coordination between multiple domain objects. A pricing engine that considers a customer's order history, current inventory, and active promotions, that belongs in a domain service. Critically, this layer defines interfaces. It says, I need something that can look up a customer, but it does not implement that lookup. The outer layers provide the implementation. The third layer is application services. This layer orchestrates use cases. When a request comes in, process this order, the application service coordinates the work. It calls domain entities. It uses repository interfaces defined in the inner layers. It may trigger events. It never contains business logic itself. Its job is to coordinate, not to decide. The fourth and outermost layer is infrastructure, and this is where everything that can change lives. your database, your web framework, your email provider, your message broker, your user interface, your test doubles. All of these plug into the application from the outside. They implement the interfaces that the inner layers defined. They depend on the inner layers. The inner layers know absolutely nothing about them. This is the dependency rule, and it is the law of onion architecture. All coupling flows inward, never outward. Let us trace a real request through the onion to make this concrete. A user submits an order through the web interface. The user interface, sitting in the outermost layer, receives the request and calls an application service. The application service is responsible for orchestrating this use case. It calls the order repository interface, defined in the domain layer, to check whether the items are available. The repository interface is implemented in the infrastructure layer by a concrete class that queries the actual database. But the application service does not know this. It only knows about the interface. The application service then calls domain entities to apply business rules. Can this customer place an order at this quantity? Does this promotion apply? Those decisions happen inside domain objects. The application service collects the result and calls the repository interface again, this time to save the new order. It may also call a notification port to send a confirmation message. Again, it does not know whether that notification goes out by email, by text message, or by push notification. It only knows the interface. The response travels back outward, from application service to user interface to the waiting user. Notice what happened. The domain model made the business decisions. The application service coordinated the workflow. The infrastructure handled the technical details. No layer reached past its neighbor. No business rule was contaminated by a database type or a framework class. This is onion architecture working as designed. Now, the most practical part of this video, because understanding the theory is only half the challenge. The other half is not introducing the mistakes that quietly destroy the architecture over time. Mistake 1. Putting repository interfaces in the infrastructure layer. This is the most common error. The interface for accessing an order, the contract that says "give me an order" by its identifier, belongs in the domain layer, not in the infrastructure layer. The domain defines what it needs. The infrastructure provides it. If the interface lives in infrastructure, the domain is now coupled to the outer layer. The dependency arrow points the wrong way. Mistake 2. Writing business logic inside application services. Application services orchestrate. They do not decide. If you find yourself writing conditional logic about how discounts are calculated or what makes a customer eligible for priority shipping, that logic belongs inside a domain entity or a domain service. An application service that makes business decisions is an application service slowly becoming a God class. Mistake 3. Controllers calling repositories directly. A controller calling a repository bypasses the application service completely. Business rules in the application service get skipped. The architecture loses its meaning. Controllers must go through the application service layer. Always. Mistake 4. Importing framework annotations into domain classes. The moment a domain entity imports a database framework, your domain is no longer independent. You cannot test it without that framework. You cannot move to a different framework without touching your business rules. The domain must remain pure. No annotations, no framework imports, no exceptions. If you have watched the earlier videos in this series, you already know about hexagonal architecture and clean architecture. Here is how onion architecture fits in. All three enforce the same foundational rule. Dependencies point inward. Business logic depends on nothing external. Infrastructure depends on the domain. Hexagonal architecture focuses on the left and right symmetry, drivers on one side, driven systems on the other, and is particularly focused on the swappability of adapters. Onion architecture is more focused on the concentric ring structure and on protecting the domain model through strict layering. Clean architecture, introduced by Robert C. Martin in 2012, combines both ideas and adds more internal detail, explicit use case interactors, entity rings, and interface adapter rings. Think of it this way. Onion architecture tells you which layer owns what. Hexagonal tells you how those layers connect to the outside world. Clean architecture gives you a detailed map of both. Jeffrey Palermo was clear about this from the beginning. Onion architecture is not for small websites. It is for long-lived business applications with complex behavior, systems where the business rules are the most valuable part and where infrastructure will change over time. Use it when you are building an enterprise application, a complex microservice, or a system where multiple teams need to work on different layers independently. Do not use it when you are building a simple application with straightforward create, read, update, and delete operations, and no expectation of lasting more than a year or two. Adding 4 layers to a simple application is overhead without benefit. Match the architecture to the lifespan and complexity of the system. Onion architecture is not a complicated idea. It is a disciplined one. The discipline of protecting what matters most, your business rules, from everything that does not matter to the business. Databases, frameworks, APIs, user interfaces. All of those things will change. Your business rules, if you model them well, should survive those changes without a single line being rewritten. The onion gives your domain that protection. One dependency rule. All coupling flows inward. That is the whole pattern. Now, have you used onion architecture in a real project? What layer caused the most confusion when you first started? Drop it in the comments. Your experience is exactly what helps the next developer watching this video find their footing faster.